Hello everyone, I, Nensi, here with my team members Isha and Rakshit to present you the topic that is pharmaceutical powders. So these are the contents I am going to cover today. The first one includes pharmaceutical powders. As we know that pharmaceutical powders are in dry form and they are the mixture of drugs and chemicals. They can be used for internal and external purposes. So the classification of powder include powder for external use, powder for internal use and special powders. In powder for external use, we have four types, that is dusting powders, insufflation, diluting powders and densifiers. In internal powders, it include dividend powders and bulk powders, and in special powders it include eutectic mixtures and efflorescent mixtures. So today we are going to focus on dusting powders, efflorescent powders and effervescent powders. So the first one we'll be seeing is the dusting powders. As we know that dusting powders are non-toxic preparations as they have been applied on the skin topically and they have no systemic action. The characteristics include that they are very fine and homogeneous powder, they are free from irritation, they should flow easily, they have good covering capacity with good absorption and absorptive capacity. They flow easily on the surface and spread uniformly. They cling or adhere to the skin after its application and they protect the skin from the irritants caused by friction, chemical irritants and moisture. There are two types of dusting powders which include medical and surgical. So the first one includes medical dusting powder. They are generally applied superficially on the skin and they are not applied on the broken wounds or on the open wounds. They should not be sterile, but they should be free from pathogens and they contain antibacterial and antifungal agent. The formula for the dusting powder includes talc, kaolin, zinc stearate, precipitated chalk, boric acid and salicylic acid. So the role of talc, kaolin and zinc stearate is to improve the adhesion and absorbency. And talc has an additional role of good slip properties with good adhesion power. So the next one is boric acid, which acts as a buffering agent and also as an active pharmaceutical ingredient. And salicylic acid, which is an antibacterial agent. Now the second type is surgical dusting powder. Surgical dusting powder are generally sterile preparations and they contain antibacterial agent. They should be instilled into the body cavities or they can be applied on burnt areas, and they also have been used in umbilical cord for infants. So the surgical dusting powder includes bacitracin, which mechanism of action is by disrupting the cell membrane and cell wall. Then comes neomycin. They are the aminoglycoside which disturbs the essential protein synthesis. And the third one includes polymyxin, which mechanism of action includes destruction of the bacterial membranes by binding it with the phospholipids. Now my other team member Isha will continue the effervescent powders.
So, effervescent salts are granules or coarse to very coarse powders containing a medicinal agents in a dry mixture usually composed of sodium bicarbonate, citric acid and tartaric acid. And when this composition is added into the water, it will liberate the carbon dioxide, which will result in effervescence. And this carbonated solution will mask the taste of medicinal agents. And this sudden and rapid effervescence could overflow the glass and leave the little residual carbonation in the solution. So, a combination of citric acid and tartaric acid rather than the either acid alone avoid the certain difficulties. When tartaric acid is used as the sole acid, the resulting granules readily lose their firmness and it crumbles. And when citric acid alone results in a sticky mass which is difficult to granulate. Now, let's see the formula of effervescent powder. It includes sodium sulfate, which acts as a saline laxative, then citric acid, which imparts acidic taste and provide water of crystallization as a granulating fluid, then tartaric acid, which provide water of crystallization as a granulating fluid, then sodium bicarbonate, which will act as a base. Now we move forward towards its method of preparation. In that there are two methods. First is wet and second is dry or fusion method. First we will discuss about wet method. In wet method, the source of binding agent is not a water of crystallization from the citric acid but the water added to the alcohol as the moistening agent, forming the pliable mass for granulation. Now, second we'll discuss about dry or fusion method. In that, the powder blend is heated to liberate the water of crystallization which will act as a binding agent. Then, this mixing of powder is performed as rapidly as in a practical, preferably in an environment of low humidity to avoid absorption of moisture and a premature chemical reactions. Next topic will be covered by my other team member.
Efflorescent powder. The efflorescent powder is the classification under the powder dosage form, solid dosage form. Efflorescent powder is solid crystalline powder. Efflorescent powder shows the basic characteristic or the property that it does not absorb the water from external environment. Apart from this, is release the water from inside their molecules to the environment and become an anhydrous or less hydrous. The most common example which we use in day-to-day life of efflorescent powder, that the sodium carbonate. The sodium carbonate shows the nature like efflorescent powder, that it cannot absorb any type of water from their external environment. It lose the water and become an, that's why we call as an amorphous substance. And second example and the best example is copper 2 sulfate, which we called blue butyrols, that also shows the property like efflorescent powder. So as we know that efflorescent does not absorb the water from external environment, so it does not form any type of solution because it is not an affinity with their water component. Now we will compare the efflorescent powder with delisquents and hygroscopic powder. On the basis of their basic characters and some other points. First point we will take that as we know that efflorescent powder as absorb the water from their external and does not absorb the water from their external environment. Apart from this, it releases the water to the external environment, but delisquent powder absorb the water from external environment. In the case of hygroscopic, it can absorb and adsorb the water from external environment. Second example we will take that it is in crystalline form. Delisquent powder is in desiccants form and hygroscopic powder in is humectant forms. Okay, as we know that efflorescent powder is not an affinity with their water, so does not form the solution. In the case of delisquent, they have very high affinity with water, so they form the solution easily. In the case of hygroscopic, they do not form the solution, but they absorb the water vapor on their surface. Thank you for watching.